Hi, I want to talk briefly about higher degree polynomials. Right, and graphing them. So let's look at a polynomial. Let's say y equals x times x minus 1 times x minus 2. So I can graph this equation, y equals this polynomial, by finding the zeros. And I know that it's going to have to go over and through each of these zeros. The sign of my function will change each of those. Here's what I do. A mark on this, x equals 0, x equals 1, and x equals 2. And I know that the largest coefficient of this polynomial is positive. So this is going to end up somewhere way up here. But I'm going to have to change sign whenever I get to one of these roots. So it's going to look something like this. Now, how did I know these were going to change sign? Maybe it came through and it bounced. Right? Well, it can't because it's only degree 1. Each term is degree 1. In fact, it's an odd degree. So if I'm going, for example, through here, 0, 1, 2, as I go through 2, this term and this term are still both positive. But this term in my product switches from being positive to negative. So I know it goes through. If I had an equation where this was a higher degree, okay, and it was an even degree, then that would be different. So let's say we were to graph y equals x times x minus 1 times x minus 2. And now I'm going to make it squared there. Notice it's blue now. This is going to have the same zeros. But look what happens. It's going to look like it's going to bounce. Now it's going to go through here. And it's going to go up. So the blue curve looks different. All right. So now that gives us our basic idea of how to graph things. And if we're uncertain, we can make what's called a sign chart and test values. So let's do that for the first example. All right. I wanted to go to the first, back to the first one. I didn't know what exactly was happening. I can do the following. We have 0, 1, and 2 on a line. And now I can plug in a number into x. And I'll say, hey, if x is 3, this is positive, positive, positive. This region is positive. If x is between 1 and 2, say it's 1.5, positive, positive, negative. Because this is 1.5, 1.5 minus 1 is a half, and this is a negative number, negative a half. So a negative here. If I plug in a half, I'll get positive, I get a negative. So my sign graph, S-I-G-N, will be this, and that will correspond to being positive up here, negative in this region, positive here, and negative here. I could do the same thing with my blue graph, but if I did that, we would find that was positive here, but it's also now positive in this region, from 1 to 2. Let's see what happens when I plug in 1.5. So I plug 1.5 in, 1.5 times 0.5, positive. Now this quantity x minus 2, when x is 1.5, is negative, but we're squaring it. So we end up with a positive number here. We got a negative and then positive, and that corresponds exactly what we see on the blue curve. So if we want to graph things, we need to understand, polynomials especially, we need to understand their roots really well. Now, before I discuss that, I want to address one question, an issue. You might say, well, okay, if I'm doing the sign trick here, rather than thinking directly about the roots, how do I know it doesn't jump somewhere? And the key is that we can draw a polynomial without taking our marker off the paper, or our marker off the board, or our pen off the paper. And we'll discuss functions like that, which are called continuous functions, where you can draw them that way more later. All right. But this makes factoring really important. Okay? If I give you something that's factored already, this shouldn't be too hard. But maybe we don't already have it factored. So we're going to try to talk about how to factor a little bit, how to find roots of polynomials. So we've already discussed the quadratic formula, and that can be helpful, but we may need to use that in succession. So one method, which you hopefully saw back in Math 45, is grouping. So an example of that is, what if I have the polynomial x cubed plus x squared plus 2x plus 2. And I want to figure out what the zeros of this polynomial are. Well, I might recognize that I can tactically group things. I'm going to pull an x out of the first part, and that gives me no, I'm going to pull an x squared out of the first part. I can pull an x squared out. That's x squared plus 1. And now I can pull an x plus a 2 out here. And this is x plus 1. And hey, now I have an x plus 1 in both pieces. So we'll pull it together. So this equals x squared plus 2 times x plus 1. So this polynomial is 0 at x equals and at goes plus or minus I root 2. The second two roots here aren't going to matter when I'm graphing it on the real line. We're only going to care about this root. So, but these are roots, but they won't matter when you go and graph it. Okay. Another trick we can do is substitution. So what do I mean by that? Look at the following example. Let's say I have the polynomial t the fourth minus 6t squared plus 8. Well, that's a little hard to work with, but I can recognize I could actually substitute t squared in for another variable. So I'm going to call t squared to be k. And now this becomes, this quantity is k squared, because it's t squared squared, minus 6k plus 8. And that's a quantity I can factor. This is k minus 2 times k minus 4. And that equals t squared, I'm going to plug the k back in, minus 2 times t squared minus 4. All right, and those are things now we can find the roots of. So the roots of t equals plus or minus square root 2 on this factor, and t equals plus or minus 2 on that factor. That's coming from t squared minus 2 equals 0, so t squared equals 2. And that gives you plus or minus root 2. And the same sort of logic, t squared minus 4 equals 0. So t squared equals 4. T squared equals 4, and then you got the other pair of terms. All right. And we'll go over more of this hopefully next class.
Mhm.